We will start the class now. Okay, you are able to listen my. Am I audible?
Sir, your voice is breaking, sir. Yes, it is clear, but breaking, sir.
Okay, okay, you are able to listen my voice, no? My voice is audible to you now. Correct?
Yes, sir, it is okay for now.
Hello.
Yes, it is audible, sir.
Okay. Okay. I am adding whoever comes. I am adding. You tell any issues are there. Either you come through chat or you unmute the call and you inform me. Okay. Everyone, you were able to see my screen. You were able to see my screen. Okay. My name is PM Subramanian. I recently joined as a faculty in automobile department, and previously I have been working in Katwa Vinayagar College. And regarding my qualification, I have completed my BE in Mechanical Engineering and ME Automobile Engineering. And I'm having a teaching experience of about 10 years. Okay? So I'll be handling a course Engine and Vehicle Management System for you in this semester. Okay? If you are not able to listen or if you are not able to see the screen, you please intimate me, okay, so that I can rectify it. Okay? Hello. Okay, I'm going to start the class now. Okay. Anyone, please unmute and please give the reply by oral so that immediately I can respond to you. Okay. Anyone is there? So please unmute and give the reply.
Okay, sir.
Okay, you are able to see the screen now,
Yes, sir.
Yes.
and my voice is clear now.
Yes, sir.
Okay, shall we start the class now? Shall we start the class? Hello? Someone unmute and give the answer. Shall we start the class?
Yes,
No
sir.
response. Okay. So regarding this course, 808701 Engine and Vehicle Management System, it is completely a theory paper, and scoring a good grade is not a difficult task. If you are studying all the topics and if you are presenting well, you'll be able to get good marks. Easily you can prepare by understanding the concept, and by presenting well, you can get good marks also. So regarding this course, uh, 5 units in that first unit will be fundamentals of automotive electronics. Okay, so in that you'll be studying about automotive electronics. What are the different control strategies? That is Fusee Logic, adaptive control, then open and closed loop control strategies. So similar to this, you'll be studying in first unit. Okay, and in unit two, we'll be studying about sensors. That is, what are the different sensors and what are the function. For example, exhaust sensor. Exhaust sensor will sense the oxygen level in the exhaust manifold. Okay, so what are the different sensors and how it's going to work. And third unit will be SI engine management. That is a spark ignition engine management that will be operated on gasoline fuel. So how to operate the SA engine electronically, and what are the components and what are the sensor and how the devices have been functioning. For example, electronic ignition system. You can see a mechanical combined with the electronics that will be used for managing SA engine performance. Okay, so we will be discussing about the application of electronics in SA engine management. And fourth unit we will be studying about CA engine management. That is a compression ignition engine management. There you will be using diesel fuel. Okay, so you'll be studying about electronically controlled unit injection system and common rail fuel injection system, EGR valves. So everything in combination with the electronics you'll be studying. And unit 5, you can see engine and vehicle management system. So unit 5, you will be studying about vehicle management system. That is not related to engine. It is related to vehicle. That is how the ABS is going to work, how the suspension can be controlled electronically, and how the seat belt tightening. So other thing, vehicle security system, collision avoidance warning system. So similar to this, we'll be studying in unit 5. And today I will be completing a unit 1. That is, we'll be discussing about fundamental of automotive electronics. Okay. So in that unit, no, first we'll be discussing about open and closed loop control strategy. Microprocessor architecture you might have studied in previous semester. Okay, if time permits, I will be discussing it in later. Because most of the university questions are coming in this area only. That is open and closed loop control strategies, PID control, lookup tables, and Fusee logic, adaptive control. Then what are the parameters to be controlled in SA and CA engines? Okay, so these are the things you are going to discuss. So first of all, I will start with the control system. That is how to define a control system. From the name itself, you can understand control means you can control other system. Okay, so control system is a component, or we can say it is a device. It can regulate the operation of other system. For example, see in a vehicle, you will be having a ABS, that is an anti-lock braking system. Okay, so this ABS can control the operation of a brake. That is, it can regulate the operation of other system, that is brake. So I can classify ABS as a control system which will control the brake. Okay, so control system can regulate and monitor the operation of other system. Okay, so whichever system is going to get controlled, I will be naming it as system plant. So you remember this word, which system I'm going to control, that is known as system plant, and which system is going to control is known as control system. Okay? So in controlling system, we can use the other word also. I can use the word electronic controller, because I will be controlling electronic means that is I will be using a sensors and I will be getting the input, and based on that I will be generating another electric signals, and that will be used for activating a component to control the systems. So the process is going to take place electronically. So I can use the word electronic controller for a controlling system. And this one will be the requirements of control system. Yeah, you can expect two more questions. What are the requirements of control system? That is, my control system should function accurately and it should have a quick response. Accurately means what is the desired function? It has to do the desired function without any deviation. Okay, so when any error is going to happen, I can't achieve my desired objective. Okay, so I will be bothering about my accuracy. I can't make any compromise in the accuracy. So I can't. I have to ensure that my control system should function accurately. That will be the primemost requirement. And the second one, the wordings are maybe simple. You can simply read and write, but you have to understand the meaning of that words. Quick response means my control system should quickly respond to my inputs. That is desirable. See, I am presenting a PPT to you. I am asking one question. Okay, what do you mean by controlling system? If you are taking too much time, your response is very late or very poor. You have to quickly respond to my questions. That is desired from you. Okay. So similarly, control system should be quickly responding to the inputs, and it should be controlling other system based on that response. Okay. So I will be desiring this quick response. And other thing is it should be stable. Okay. It should be stable. See, if anyone is want to join, no, please others you unmute the call and intimate me so that I can go to the Google Meet and I will admit them. Okay. Next one is control system should be stable. So stable means that is it should not oscillate. Okay, that is oscillate means the how the manner it is going to control the system. Uniformity should be there. That is it should be the system plan should be delivering the output that should not be varying. Okay, that should not be unstable. So control system should be able to control the other system in a stable manner, and it should respond only to valid inputs. That is whatever inputs required for the control system, that only it has to take. It should not respond to other inputs. So valid inputs only the control system have to respond. Okay, so these are the main requirements of control system. And next, I'm going to explain you open loop control. This is one of the control strategy. Open loop control means you can see, first of all, there is no feedback. From the output, I will not have any feedback. That is the open loop control. So what is happening here? No, I will be giving one input. Say one input is given to control system. Here the control system is electronics controller. Okay. So input is given to the controller. So this controller will receive this input, and what it will be doing? No, it will be generating a electric signal. That is I. Okay, you understand the word. This controller will generate an electric signal. That is I. The I will be given to that output of the controller. That is a current that will be fed into the activator. Activator means it will be doing mechanical work, whereas electronic modification of that input, that is what is the desired signal required for activator, that will be decided by the controller based on the input received. Okay, so the electronic controller will direct the activator, so that for directing it, it will be sending the electric signal Y. Okay, so now the activator based on this electric signal will deliver a force. Okay, it can deliver a force, that is U. You can say displacement or whatever it may be. What is required from the activator? Okay, so it will be delivering that, and that will be fit into the plant. See, I told you, no, a plant is the one which is controlled by a system. System here, control system is electronic controller, which is going to be controlled. That we will be calling it as system plant. So I'm going to control this plant by means of electronic controller. For controlling this plant, directly I can connect the electronic controller to plant because it can't respond to this electric signal. I want to convert my input into other form, so that only I'm using what actuator. Okay, so plant will be responding to this output from the actuator. That is, it may be a displacement, and it will be giving a output. Okay, so what I'm doing is for the input, I will be controlling the plant to give the output. But the major drawback of this system is if any disturbance, okay, it is not inside this system, it is coming from outside, a noise. Any disturbance is going to come here, I can't make a change. I can't respond to the disturbance. For example, if someone is going to disturb that class, okay, during this Google Meet, what I can do is I can mute them. I can consider me as a control system. I will act. I will send. Say I will be using the mouse, and I will be clicking that their email ID, and I will be muting that call, so that that will be my response. Okay. So here my control system can't be responding to this disturbance. Okay. So that is a major drawback in open loop control. So this one related to a example I can explain you. So in automobile you can see a damper. Okay, damper means it will be providing a damping to control the amplitude of the vibration. Okay, so consider the damper as an activator. So it will be giving a force. Okay, it will be giving a force to control the vibration. My plant is a vehicle. Okay, I have to reduce the vibration. So the vehicle will be traveling over the road. So I will be getting the input. So for this given road, I will be doing the required calculation. That is, I will be doing what to do to reduce the vibration. So that based on that, I will be sending the electric signal, that is to the damper. So damper will be giving the force, that is a damping force to the vehicle, so that I will be getting the desired output. That is my amplitude of my vibration will get reduced. Okay. So already I have told you it can't respond to the disturbance. Okay. So what are the characteristics of open loop control? I have enumerated here. My output is not compared with the input. That is, I can check my output is related to my input. For this given input only, I am getting this output. Whether both are what to say, whether both are justified, or whether there is a relationship existing between input and output. So I can do this in open loop control. Okay. So my operation of the plant is immediately before the plant I am having activator. Okay. So my operation of the plant is directly regulated by the activator. Okay. So I can't have another system to control my plant. Okay, and another thing is I'm having a inability. I already explained you to compensate for changes. Any disturbance is going to act. I can I don't have any capability to compensate for the changes. Okay, so that's all about open loop control. If you're having any doubts, you can ask me. You please unmute the call and you please inform whether you have understood or not. Anyone? Anyone is listening? Hello? You're having any doubts?
No doubt, sir.
Daniel? No, don't know. See, whenever see, I am checking your response. Okay, I will be taking class for 10 minutes. Then I will be asking you to reply. That is whether you have understood or any doubts. So immediately you have to unmute the call and you have to give the reply. Then only I can ensure that you are attending the class or not. Otherwise, you might have simply joining the meet and you will be keeping the cell phone somewhere. Okay. So I need a response from you.
Sir, okay, sir.
Meenakshi Sundaram.
Sir,
Okay. So whenever I'm asking question, you unmute the call and reply. Okay.
okay, sir.
Okay. Now you can unmute. Okay. Next, we'll be discussing about closed loop control. Okay. Closed loop control. You see the sketch. You have to draw this layout. Okay. For this course, you have to remember the sketch. That is the layout of the system. And based on this layout itself, you can be able to explain. Okay. So here you can see, I'm taking the output. That is, I'm taking the output from the plant, and I am sending into the sensor. And from the sensor, I'm going to do the signal processing. Why signal processing? No, I will be modifying the output to readable form. That is so that the controller can respond to it. Okay, so that only I'm having a signal processing. Okay, from the output, I will convert that output into a signal that can be processed by my controller. So that only I need a signal processing. So in this unit, the same thing. I am getting a input. Okay, so I'll be having a controller, that is we can say control electronics or electronic controller. So it will be sending a control signal, that is a electric signal I. Okay, so it will be sent to activator. Then from the activator, I'll be getting a, the actuator will be delivering a force, can be a force, displacement, whatever it may be, to a plant. That is a which system I'm going to control. Okay. So from the plant, I will be getting the output. So here you can see, I'm measuring the output. I'm taking the output and converting the output into a suitable form. That is by using a signal processing. Then I will measure whether my output is having the desired value or not. For example, the same example, okay, that is a vibration. I am going to do vibration in the closed loop system. That is, instead of actuator, you consider about damper. It is our vehicle, you say passenger car, and the output is a vibration of the sprung mass. That is vibration of the passenger. Okay. For example, say vibration amplitude 5 mm. Okay, 5 mm I am getting. Okay, and the desired value should be 3 mm. So error is 2 mm. Okay, so error is 2 mm. So based on that, the error, the controller will be working. So this much error is coming for this input. So what I have to do so that the error will be 0. For that input, this much error is coming. So I have to modify my control strategy in the controller, that is electronic controller, so that the control signal should be modified. So that modifying the control signal, the force will be changed, so that I will be getting the desired output, say 3M. Okay, so I am getting a feedback from the output. And similar to this, if any disturbances outside the system, okay, some disturbances are going to come, and see there is a change in the output. So I can understand that previously, before disturbance, the output is meeting the desired value. So due to some disturbance, the output is going to change. So again, I will modify the control strategy to address the disturbance, so that I will ensure that always my output meets the desired value. Okay, so that is a closed loop control. So the characteristics of closed loop control you can see here. I am measuring the output variable. That is, the output variable is measured by a sensor, and the feedback is given to the controller. Okay, so I am comparing the measured value with desired value. This is very important. What I say, I am getting 5 mm means my desired value is 3 mm. So I have to compare it, okay, whether the output is having a desired value or not. So I have to find out the error. There is a desired and actual. That is what value you are aiming for and what is the actual value. So you have to find out the error. Okay. Then controller generates a activator signal. So already I have told you. So how the controller will make this activator to generate a signal U? If the error should be zero. Okay. So this closed loop control system will improve stability and it will be addressing the disturbances in the system. Okay. So now let me ask one question to you. Meenakshi Sundaram is there? Meenakshi Sundaram.
Yes, sir.
I'll be asking one question to you. Okay.
Okay, sir.
Which system is preferable when disturbances are existing? That is, which control system I will be going for when disturbances are existing. Okay, whether it's open loop or closed loop for effective control.
Open loop, sir.
How? See, if the disturbances are there, I have to address the disturbances. I have to make an effective control. So I have to go for open loop or closed loop. Hey, any other? Karthik, Manigandan, Pranay, Preeti. Who is willing to give the answer?
Closed loop system, sir.
Okay, good. See, you have to listen the class carefully, okay? Since it is through Google Meet, some disadvantages will be there. So you have to pay attention to the class, okay? So if you are not able to understand anything, you unmute the call and you ask me. Hmm? So next we will be starting PID controller. Okay, we are going to see different types of controller. That is how the control strategy is going to vary. Okay, PID controller. Okay, so what is this PID? You know, proportional, integral, derivative. Okay, proportional, integral, and derivative. What is proportional? No, that is based on present state. That is a control system is working, and I am getting a error. Based on the present error, I will be multiplying this error with the gain. Okay, this gain is to address the error. So that input will be given to that process, so that the output, the error will not be coming. The error value can be reduced. Okay. So proportional means present state. That is now at present. Okay. Whereas integral means it is a past. You can see integral means here there will be a integral, a summation of a error terms from the past. So based on the history, I will be adding all the errors multiplied by the gain. I will be giving the input to the system, so that it will be rectifying the output to be error free. Okay. And next is derivative. Derivative means future. P present, proportional present, integral past, that is summation of all errors. D is derivative. Derivative means I will anticipate the error. That is, I can understand the present trend. I can decide what will be the error in the future. In order to counteract that error, I will be using this derivative controller. Okay, so that my error value can be reduced. So this type of control strategy is used in PID controller: proportional, integral, derivative. Okay, PID means proportional, integral, derivative. Okay, so here we will be having a generic control loop feedback. A feedback is there. It is not an open loop control system. It is a closed loop control system. So you can see the output is coming here. So then it will be calculating the error. So the three things will be going: present state error, past state error, and what will be the future error. So everything will be summed up. You can see I will be adding all the error, that is present, uh, past and future, so that I will be getting one value. That value is known as magnified value. That value will be given to the process, so that my output, this error value, will be reduced. Okay, so like this only it will be performing. That is a PID controller. Where I will be using this PID controller means it is used in industrial control system. Okay, for industrial applications, I can use this PID controller. So this one, what we are discussing is in theory part. Okay, that is how the controller is going to work. But in actual case, we have to design the components, so that we need devices to work on this. That is, I need devices to compute the present error, and we need devices to control the past error. So practically, we have to make this controller into existing. That will be the most difficult part. Okay. Theoretically, we can say present, past, and future, but practically, we have to implement this controller for achieving our desired output. That is very, very essential. Okay. So now, error, already I told you, I will be getting an output. I will be having a desired set point. The appropriate word we can use is a desired set point. So measured process variable and desired set point. That difference is known as error. Okay. So we can say, what do you mean by error is the difference between measured process variable and desired set point. Okay. So what will be the main function of this PID controller is to minimize the error. Okay. So I have to minimize the error. For that, I am modifying the input. For the given process, I will be having a error. In order to minimize this error, I will modify the input. See, for example, I am summing up these three control strategy, that is a present, past, and future. I am giving on another value to my input, so that my error value will get reduced. Okay, so we can say the word PID controller as three term control. That is a P, present error; I, accumulation of past error; and D is prediction of future errors. Okay, so you can see I am giving what? Yes, a sum is given, and you can see the word weighted sum. Why weighted sum? No. For this error, I am multiplying this error term by a gain. That is, for present, I am using KP. For past, I am using the gain term KI. And for future, I am using the gain term KD. So for I am considering the weight. Okay. So when I am increasing the weight, I am concentrating on that error. If I'm increasing KP, I can say I am concentrating more on present error. Okay. So what are the characteristics of PID controller? No, that is, whatever the process is there, you no need to bother about the knowledge of that process. Whether you know about the process or not, you can use the PID controller. So this one will be the main characteristics. That is a no knowledge of the underlying process. So we can use the PID controller. And the most drawback is I can't say this is the optimum control. That is, when I'm using the PID controller, I'm having a control over the system. Okay, I can't say this is correct, this is optimum. Yeah, and also I can't assure system stability. I can't say by this control the system is stable. That also I can't guarantee. Okay, so that is the main drawback of this PID controller. So you can see here in PID controller, we are having P, I, and D. There are three terms. For most of the applications, we will not be using all the three terms, that is proportional, integral, and derivative. We will be using any two, or otherwise you will be using P, or otherwise you will be using I alone. Okay. So you can see a PID controller, if I am not using the derivative term, that is, I am not bothering about future error, it will be a PI controller. Okay, PI controller. When I am not bothering about integral, that is when I am not bothering about past. So I can say PD controller. Okay. So if I am going to concentrate on P as well as I, okay, that is only P means I can say P controller, I means I controller. Okay. So here there is a value called magnified value. See, I have shown you U. Okay, U will be by actuator. So for PID controller, my U will take a value that is MB means magnified value. That will be the summation of this three terms. That is a proportional, integral, and derivative. So already I have told you KP is a gain. So I can use the other word. I can use a weight. I can use a weighting factor. Otherwise, I can use the word tuning parameter. Okay. So KP can be termed as a tuning parameter, whereas KI can be termed as a integral gain tuning parameter. Okay. So all this KP, KI, and KD can be termed as uh, a gain, a tuning parameter. Okay. Next, we'll be discussing about all these three terms independently. So, when a question is asked related to 8 marks, related to PID controller, what you have to do is you have to give explanation for this slide and this slide alone. These two slides will be sufficient for 8 marks. If the same question is asked for 16 marks, you have to give explanation for all the three terms. Proportional term, you have to explain elaborately. Integral term, you have to explain elaborately. And derivative. Okay. So now we will be seeing a proportional term. Any doubts? If you are having any doubts, you can unmute and you can ask. If no doubts also, you can unmute and you can say you can proceed to the next topic. No one is responding. Right? Were able to hear my voice or not? Hello? Okay. Next topic, I am going to see about proportional term. So what are the characteristics of this proportional term is, already I have told you, it is based on the current error value. So this P proportional term, it will change the output proportional to the current error value. You can see the formula AP into error. Okay, so whatever the error, proportional to that, I will be changing my input. Okay? So I will be multiplying the error by a constant called Kp, which is termed as proportional gain. Kp is called as proportional gain, and Ki integral gain, and Kt derivative gain. Okay? So proportional term, we are having a proportional gain called Kp. So let us see what will happen if I am going to increase this Kp. So you can see here, this is my ut. Okay, you don't need to bother about other two terms, Kp into Et. Okay, so I am having a low value of Kp. Okay, low value of Kp means for a given error, my response is poor. If I'm having high value of Kp, I am too sensitive. I am responding to the error well. Okay. So you can see a high proportional gain when it will come no, when there is a large change in output. So due to any disturbances, there will be a change in output. Okay. So the change in the output will be more. Okay. So due to that, I will be increasing my proportional gain. My proportional gain value will be high. So what will happen due to this is the system can be unstable. I can't assure that system can be stable because I have increased my proportional gain to a high value. The system can become unstable. Okay. Whereas when I'm decreasing this value, say a small gain for the output, I can say the system is less responsive, and I can classify the controller as less sensitive controller. Okay. So based on the value of the proportional gain, I can say whether the system is unstable or whether the system is less responsive. The proportional gain value is high, I can classify the system as unstable. The proportional gain value is less, I can classify the system as less responsive or less sensitive controller. Okay. Next, there is a defect in proportional controller, that is a P controller. Okay, I'm using the word proportional term, that is I am using the word P controller. Instead of PID, I'm using the word P controller. That is what will happen now. There is a error called droop. What do you mean by droop is, it is defined as process gain by proportional gain. Why this droop is coming now? When you are having a setup point, okay, that is a target value. When you are doing a optimization process, okay, when you are controlling the system, when you are controlling a system, you will be having a value. The value should be say 5. But due to this proportional gain, what happened? The value can go below that. Okay, so drooping will take place. Okay, so whenever it will not settle at a target value, and it will be going below this. Okay, so that is known as drooping. That is, you might have studied in engineering materials. That is annealing. Okay, you will be cooling the metal component in a furnace. So what happens sometimes? It will be cooling below the desired temperature. Okay, so that type of error can be termed as a droop. So going to a value below the desired value can be termed as a droop. Okay? So droop can be defined as, that is, I can say droop is proportional to process gain and inversely proportional to proportional gain. Process gain means due to that process, okay, I will be doing one work. That process gain, it is directly proportional. That is, the process gain is getting increased means my error will get increased. Okay. So how to counteract this error is I can go for increasing my KP so that I can reduce my error. Okay. So for purely proportional control, droop is the peculiar defect. Okay. When I am going for a P controller, the major drawback will be the droop can come. So the droop should has to be compensated. That is, instead of going for a proportional control, I have to add an integral term. That is, I can go for PI controller. Instead of P controller, I can go for PI controller to address this droop. Okay. So you can see the graph. That is three values. One, the green color will be common for all the three terms: proportional, integral. That is KP1, KI1, KD1. Okay. Whereas if I'm going to increase my KP, what happens? When I'm going to decrease my KP, what happens? You can see when I'm decreasing my KP, that is KP is 0.5. Going above the reference signal is known as overshooting, and below the reference signal, I can classify it as a drooping. Okay, so when I'm going for a low value of Kp, this problem is going to happen, and you can see when I'm increasing this T, the error value is getting reduced. Okay, so this graph explains how Kp, the change in Kp modifies your output. Okay. Next, we'll be discussing about integral term. If you're having any doubts, shall we proceed to integral term? If you're having any doubts, you can ask for question. You please unmute and answer. whether you are in the class or not. Dinesh Khanna, Karthik, Manigandan, Satish Dinagaran. Hello. Hello. Unmute and answer. You are able to listen or not? Hello, Preeti. You are able to listen. Unmute the call and answer.
Yes, sir.
See, you have to stay in the line, okay? Whenever I am asking any question, you have to answer.
Okay,
Okay.
sir.
Next, we'll be discussing about integral term. Okay. Previously, discussed about proportional. Now we'll be discussing about integral term. See, in a proportional, no, what they will be doing, they will be concentrating on magnitude of the error. Okay. Whereas integral, it will be taking account both magnitude as well as duration. Okay. It will take both magnitude and duration of the error. So my integral term will take the magnitude as well as duration. How the duration is going to take into account is, you can see the integral. It is related to 0 to t. I am calculating the error for the past period. Okay, so I am considering the duration of the error, when the error is going to start and till present. What is the error? Okay, I am going to sum up the error values. Okay, so What I can do is in the integral term, it is a sum of instantaneous error over time. Okay. So by this integral term, what I am going to do is I will be modifying my input so that the output will move towards the set point. By providing this integral term, I can make my control system to control that plant so that it will be giving an output that will be moving towards the set point. Okay, so that I will be eliminating the error. Okay, so the basic drawback is sometimes overshoot will happen. Okay, whereas in the previous term proportional undershoot there is a drooping will take place, whereas in integral overshoot will take place. Okay, so you can see here when the one graph is same, that is KP1, K1, KD1 being having a green color sketch. If I'm going for a K value, that is I'm increasing more means you can see the problem is overshoot. Above the reference signal it is going okay. When it is a zero point 0.5, it is less than reference signal and it is matching the reference signal after a particular time. Okay. So I have to take this gain a proper value to match with the reference signal with the minimum period of time. Next we are going to discuss about derivative term. Okay. Derivative term means you can see this expression. Okay, differential of error with respect to time. That is, if you are going to plot a graph, error versus time, I'll be getting a slope. Okay, so I am going to multiply this slope with my gain. That is a derivative gain. Multiplying this rate of change of error with respect to time with derivative gain. That will be the T. That is what we can say a PID controller, no? D or the derivative output. Okay. So what it's going to do now, that is by using this derivative term, the rate of change of output is will be reduced. So previously in this overshoot happens. Okay. Whereas in this, due to this term, that is, I am going to consider the rate of change of error with respect to the time, and I am going to multiply this term by a gain. So by adding this term to my input, I can control my output. That is the rate of change of output. It will control the rate of change of output. So overshoot will not take place. So main advantage of this derivative term is overshoot will not take place. It will reduce the magnitude of the overshoot. Okay. So that derivative term will ensure process stability. And the main problem of the derivative term is when any external disturbance is going to happen, there is any noise or any disturbance which is going to come from outside, the system will become unstable. It can't respond to outside problem. Okay, so that will be the major drawback of this derivative control term. There is a derivative controller. Okay, so PID controller derivative, the term D alone. You can see here KP1 the same graph, KD 0.5, KD2, you can see it will be meeting the reference signal after a particular time. Next, we will be discussing about lookup table. That is the next topic in our syllabus. Shall we start? Okay, we'll be starting this lookup table. Okay. What is this lookup table? No, it is like a array. Okay, that is I'll be having a relationship between two variables, and the relationship will be stored in the computer memory. So whenever I want to find out a value, I will refer that table, that is a lookup table, and based on that, I will be finding out the required value. That is a lookup table. Okay. So see here, consider there are two variables. Okay, x and v naught. There are two variables x and v naught. There is a relation existing between x and v naught. Assume x as an input and v naught is the output. There is output voltage. There is a relationship existing between them, and their relationship and their values are stored in our computer. Okay, that is a computer memory. Okay? So for different values, VO, V1, V2, V3, and X1, X2, X3, all the values will be stored in a table that can be termed as a lookup table. So what I'm going to do is, in normal computation, there will be no lookup table. What I will be doing is, I have to do calculation to find out any value X. Okay, so I will not have any reference. So what will happen? The time will required will be more. When I am having a lookup table, my computation time will be reduced. Okay, so similar to your design data book, you will be using a design data book for DME. No, so when you are having any values in there, you will be taking it. That is, you will be having one formula in the, you will be referring it, and immediately you will be writing in the answer sheet. Okay, so you are retrieving the information from a reference. Okay, that will reduce your time. So similar to that, we are having a lookup table. So already a relationship between the two variables will be built. That is VO and X, and that values will be stored in the memory. And whenever required, it will be retrieved from the memory. Okay. So now how the retrieve will take place? For example, I have built a relationship between VO and X. I am having all the values. For example, I am having the value V1 for x1. V1 corresponds to x1, V2 corresponds to x2. So similarly, I am having a set of values. A array has been formed and it has been stored in the memory. Okay. So now I want to find a x for corresponding V naught. Okay. I am having a V naught. For that V naught, I want to find my x. Okay. Whatever it may be. So I am having a sensor. Okay. I will be having that input, and we will be having analog to digital converter. That will be converting the analog signal to the digital, and I will be having a multiple processing unit. So that what it will be doing now for given values V naught, V1 and V2 will be retrieved from the lookup table. That is, I will be getting a V naught. So for that V naught, what are the values nearer to V naught, V1 and V2, that will be taken from the lookup table. Then in that processing unit, a formula will be fed. This formula is a interpolation formula. That is, I will be knowing the two values. That is, for I have to find X for corresponding V naught. I will be knowing for V1 what is X1, for V2 what is X2. So I'll be using this interpolation formula and I'll be finding out the X. So this multiple processing unit will take the value of V1, X1 and V2, X2 from the lookup table, and it will be using this interpolation formula to find out the X. Okay. So this one is the working of lookup table. This formula has to be fed into the multiple processing unit. Okay. So in order to find X, I'll be having a V naught. So the V naught will be found out by referring the other two values, that is a V1, X1 and V2, X2 from the lookup table. And by using the interpolation formula, I'll be finding out the X. My interpolation computation time will be reduced when I'm going to use this lookup table. So explanation I have listed out here. So what are the additional characteristics is, I can say a lookup table is an array. Okay, so it will reduce the computation. And already I told you retrieving a value from memory is easier. So I can retrieve a value from memory, then it can going for expensive computation. Okay, I can retrieve values. So first of all, I have told you a relationship between them. For example, we can say your marks and your age. The set of group of students, their marks and their age. 25 age, they are getting 80, and 30 age, they are getting a 60. Okay, so two parameters. So two parameters, I have defined the relationship. Okay, V naught and X. So I am having a certain specific relationship. So based on this relationship, I am plotting a different values. Okay, V naught and X it is stored in the ROM, that is in memory. Okay. So whatever value V naught is going to come, that is I have to find out X. I will be do the calculations and I using the interpolation formula and I will be calculating X. So for example, I have to find X. Okay, my X will not be in the form of the magnitude. My X will be in terms of another input. Okay, that for corresponding that input, I will be getting a output voltage D naught. Now I have to find X that is from this table which I have been built using this a specific relationship. Okay, so for initially my X will not be in a desired value. How I have built that table it will be in some other form. But for that X, I will be getting a V naught, that is output voltage that will be in the desired form, so that I can refer the lookup table and I can find out the X. Okay. So for that only I am using this converter, analog to digital converter. And then I am using a multiple processing unit, so that it for Vivo it will find out the two values of V1 and V2, the nearest values. Then using that interpolation formula, it will calculate X. That is the lookup table. So based on this layout itself, we'll be able to explain. Okay. Next, I will be discussing about Fusee Logic. Any doubts in lookup table? If you want to ask anything, you can ask. Shall we proceed to Fusee Logic? Manigandan, Dinesh Khanna, are you listening? Unmute the call and give the answer. What about Pranay, Sai? Satish there? Satish is there in the line? Preeti, unmute the call. You are able to understand this lookup table and the other things what we have discussed now.
Yes, sir.
Any doubts? No, no.
No, sir.
Okay, shall we proceed to the next topic, Fusee Logic?
Sure, sir.
Okay, thank you. So others, I am expecting the reply like this. Okay, no need to text. just unmute the call and give the response so that it will be more interactive. I will have the feeling that you are listening the class. Otherwise, it will be like a presentation given by a robot. Okay? There is no feedback is received. Hmm? So I need your input, whether you are understanding or not, whatever it may be. I will be giving 2 or 3 minutes after completing the topic. You can share your views and you can ask your doubts. Okay? So whatever you want to convey, just unmute the call and you can tell. Then only I can guess that you are listening the class instead of putting a message in the chat. Okay. Next, we are starting Fusee Logic. Okay. Fusee Logic means it is a type of a control system that is our decisions will be taken based on some assumption. Okay, that is previously we might have gathered some knowledge, or previously we might have some experience. Okay, so based on that we may take some decision. So uncertainty, that is making decisions using uncertainty. Okay, that is we will not assure that our decisions are more accurate. It may have less accuracy also, and also we will be going for Fusee logic when complete information is not available to us. Okay, complete information is not available to us, so that I can make a random judgment. Okay, based on logically, random means not arbitrarily, based on our perception and based on our understanding, we will be making some logical decision. Okay, so we'll be having some knowledge. Okay, without making a knowledge, you can't make a decision. VC logic means completely will not be having a knowledge. Some partial knowledge will be having, but making the decision will be having less accuracy. Okay, so that is known as Fusee logic. Fusee means not clear or it is not distinct. Distinct means I can say this one is correct, 100% correct, and this is more accurate. Okay, so making a reasonable decision based on our knowledge what we have gathered. Okay, so that is a Fusee logic. So we can say formalization, mechanization of this capability is known as Fusee logic. This capability means what? Whenever there is uncertainty is there, whenever we don't know we don't have a complete knowledge about that system, we don't have complete information. So when this situation comes into the picture, I will be forming a control system that is Fusee logic, that is formalization, mechanization of this capability is known as Fusee logic system. Not clear and not precise, but more or less it will be reaching the acceptable decision. Okay. So based on our knowledge, based on our input, for the given input, we can make a reasonable decision. Okay. So we can say a knowledge representation that can't be defined precisely. That I can say I am having a complete knowledge in that. For the knowledge of what I am having, I can make a decision. Okay. So what it can use, no, it can be the most efficient tool to solve control system. For example, ABS we can consider as a Fusee logic system. It will be getting input from different components, say from wheel sensor and speed sensor. Sorry, it is a speed sensor. That is, it will be measuring the speed from the wheel. Okay, and it will be measuring the pipeline pressure. So we can say it is having all the values required to control the system. It will be having some partial values. Based on that, it will be working. That is when it can predict. That is when the vehicle is about to, wheel is about to lock. That is anti-lock braking means I have to prevent the wheel lock. Okay. So when a desired speed is reached, there is a desired speed means at that speed the vehicle is going to lock. So I can avoid that speed by regulating the pressure in the pipeline. Okay, that decision will be taken by Fusee Logic technique. Okay, I will not be having a complete information, but whatever information I'm having, I can make a decision so that I can prevent wheel lock. Okay. So this will be the representation of Fusee Logic. For example, our traditional representation for any system, if the speed is 0, we will say slow. If the speed increases above 0, that is 1, we will say fast, but it is not correct. Okay, fast means we should have some range. Okay, so what we have defined is speed is 0 means slow. Speed is other than 0, else means it is fast. Okay, so it is a traditional representation. Fusee logic means we are defining some context. What is the range? 0 to 0.25 means slowest. There is a slow is different from slowest. Okay, and above 0.25, zero point 0.5 slow, and for fast we are having a range. For fastest we are having a range. Okay, so these are the Fusee sets. So already I have told you in ABS we are working based on Fusee logic. So it will be monitoring the braking system on the vehicle, and it will release the brake just before the vehicle wheel slot. Okay? So the main thing is at what time, what is the best time it has to release the brake. It will be doing by Fusee logic. Okay. Uh, Next is we are going to discuss about adaptive control. What do you mean by adaptive control? Okay. See, adaptive control means I am having one control system. Okay, I will be formulating one control law. I will be having maximum values, that is positive one maximum value will be there, negative another value will be there. When all the things are going to happen within this limit, my control system will be working. That system can be classified as robust control when it is going to operate it within that limit. Okay, it can't change the control law. So I will be designing the control system that will be operating in the control law. It will be having a predefined limits. Okay, so predefined limit it will be operating, and when the limits are going to change, the control system will not be able to deliver properly. It will not be effective. Okay, it will not be adaptive to the change. So that type of control system is known as robust control. The control law is fixed. I can't change. Okay. Whereas in adaptive control, what I can do is if the limit are going to change. Okay, I'm having the limit will be changing for the problem. That is, I will be feeding one law in the control system, but the limits are not to that law, the limits are changed, so I have to be adaptive to the change. I have to modify the control law for the change. So that type of control is known as adaptive control. I will not have any prior information about the bounds on the parameter. So based on that we have to frame a control law. Okay, so control law can be changed, and I will not be knowing about the limits. Whereas a robust control law can't be changed. I will be knowing about the limits and I will be knowing about the parameter. That is a robust control. It is like full proofing. So I will make assumption that whatever parameters is going to come, already it has been designed. It will be coming within this value only. And the control system will be working in this law, and it will be delivering the required function. I will have a reliability on the system because the based on the assumption that the parameters are within that limit. Okay, but in real case we can't say the parameters will be within the limit, it will be changing. So I have to look for adaptive control system. So in our automotive we are having adaptive control system that is called adaptive cruising control operation. There is adaptive cruising control means you can see the vehicle ACC. If the ACC is fitted in the vehicle will be driven. And before that vehicle, that is in front of the vehicle, if another car is going to travel, so So what this ACC will be doing is automatically it will be decelerating the vehicle. It will be decelerating the vehicle. But sometimes it can apply the brakes also to avoid the collision, so that a safe distance will be maintained between the vehicle which is traveling front and ACC fitted vehicle. A safe distance will be maintained, and I will ensure that the collision will not take place. Okay, so that is the adaptive cruising control. So in that the different control units, what I am having is engine management control. Engine management control is I can control my acceleration of the vehicle. That is, I want to decelerate, means there are different ways. One is from engine perspective, I will close the throttle opening so that amount of charge entering will be reduced. So my engine speed decreases and vehicle speed also decreases. That is from engine perspective. And from vehicle perspective, that is applying the brake. Okay, that is I need a engine intervention. That is I will be using simultaneously from engine, and I will be using the brake also to effectively maintain the distance. Okay, so there will be a radar. Okay, you can see here a radar will be there. Radar is a light wave. The light wave will be emitted and it will be getting what to say, reflected from the vehicle which is traveling front. It will be go and touch the vehicle which is traveling front, and it will be getting reflected back, and it will be coming to our ACC vehicle. So based on that, it will judge what distance the vehicle at the front is moving. Okay, I will be setting a desired value, say 2 meter. So in order to maintain the 2 meter, my engine as well as the brake intervention will be working, and respective throttle opening and respective deceleration will be taken care, so that I will be having that distance, say 2 meter. Okay, so there will be an engine intervention as well as a brake intervention, and I will be having a control. Okay, so I will be having a sensors. I will be having a radar that is for measuring the distance, and for capturing the video, that is I will be having a navigation. Okay, in addition to radar, I should be able to capture the vehicle motion. There is a physical location of the vehicle I have to capture. Okay, for that I will be having a motion capturing camera. Okay, that will be presented in the windshield. So I will be using that also, and sensors. Sensors means controlling yaw rate. Yaw rate means about z-axis. The vehicle angular movement is known as yaw. So yaw rate sensor and other sensors will be giving input to. There will be another unit called ESP. ESP means electronic stability program, that will be controlling the brakes. Okay, so vehicle stability will be maintained. At the same time, the vehicle will be moving at the safest distance from the forward vehicle. Okay, so this can be achieved by adaptive cruise control. Since it is adaptive to the changes, I am classifying this adaptive cruising control in under adaptive control system. Okay, so let me show one video related to this. See, everyone, I will be showing on a video. Are you able to see this? That is a Bosch adaptive cruise control. Are you able to see this? You unmute the call and give the reply whether you are able to see the
Yes, sir.
video. Okay. Let me play the video. Okay. Now observe this video. The red color one is reflector one. Yeah, have you seen the video? Not audible, huh? Okay. So I will share the link, okay? It is in PPT. Hello, Dinesh. Shall we proceed? You are able to hear my voice now?
Yes, sir.
Okay. Yeah, I have shown one video related to adaptive Fusee control that has been devised by Bosch. Okay? So the main thing, first of all, I will explain this ACC is it will not be operating on all speed range. You have to remember one value that is greater than 30 kilometer per hour and up to 200 kilometer per hour. I can use ACC. When I'm going to operate less than 30, I can go for ACC. So the limit is greater than 30 kilometer per hour and less than maximum limit is 200. Okay, and also I can't guarantee that is if any suddenly one obstacle is going to come. Okay, for example, see a vehicle is going in, that is ACC vehicle is going, and in front of that another vehicle is going. If suddenly one obstacle is going to come, that is I'm going to throw one big stone between these two vehicles. Then manually I have to react. Okay, I can't expect my ACC to respond to the other disturbances. Okay, it will be contribute. It will be sensing the vehicle which is traveling front. Suddenly, if some obstacle is going to come, we have to the driver has to act. External intervention is required. Okay? So, what is ACC means? It can change vehicle speed to the changing traffic conditions. That is what is the problem in regular driving mode is during traffic. No, we have to ensure that I'm maintaining a safest distance from the for vehicle which is standing before. Okay, so my ACC will reduce our work. So due to this, when we are doing manually, we will get tired and we will have some what to say. We will get irritated also. In order to improve our comfort, the ACC will adapt the vehicle speed to the changing traffic condition. So what it's going to do is automatically the three words are there. This one you have to refer: automatic acceleration, or deceleration, or braking. So these three things only my ACC is going to do. This acceleration, deceleration, braking, it requires what? Engine intervention as well as braking intervention. Both. Not only engine, both engine and braking. Okay. So for working of ACC, I need the distance the front vehicle. The vehicle which is traveling at the front, no, I have to measure the distance based on the function of road speed. Okay, so both the vehicles will be traveling. I will be having the data of the speed and what is the distance of the front vehicle is traveling. What is the distance of the front vehicle which is traveling at the front? So that distance will be computed before starting the vehicle. No, that is before starting ACC. The driver will put. We have seen one in the YouTube. A lever is there. Okay, the driver is setting the system to ACC. That is, he is switching on the ACC. So during switching on the ACC, he has to give the input at what distance I have to maintain the gap. For example, you have seen some trucks and lorries in the highways. They will be writing you have to keep a distance of 1 meter or 10 meter. Okay, so the driver has to design that distance. That is 10 meter gap I have to maintain. And once the front vehicle is rest and it will be going, no, at what time after that that is after which time my ACC vehicle can start. So these two parameter input has to be given by the driver. So for that, the first sensor I am going to use is distance sensor. So it measures the distance, relative speed, then relative position of the preceding vehicle. That is the vehicle which is traveling front. Okay. So I will be using a distance sensor. Then it is a radar sensor. It works based on radar principle. That is I will be having a three beams that will be emitted simultaneously, and that will be getting reflected back. Based on that, I will be giving that input to the ECU, and it will be doing acceleration or deceleration or braking, so that it will maintain the required distance. Okay. So here you will be studying about these terms in the second unit, that is in sensor, propagation time, Doppler shift, and amplitude ratio. These things will be studying in the second unit. Okay. So you can see already I have told you there is another system, that is ESP, electronic stability program. Why no? In order to maintain the vehicle stability, that is I will be getting an input from different sensor. Yaw rate sensor. Yaw means angular moment about z axis. Okay. Then input from steering wheel angle, wheel speed, lateral acceleration. So from all this parameter, I will be getting the input, and ECU will regulate the braking. Okay. So other things input is video imaging. Already I have told you, video imaging and navigation system will give the input of the presiding vehicle, and radar signals also. I will be giving the traffic flow information. Okay. So already I told you there will be an intervention from engine side and brake side. So in this ACC, I will be using a engine that is not a conventional engine. I will be using electronic engine power control system. That is, I will be controlling my engine electronically. Okay, then only I can use it in my ACC. So that how to achieve this? That is when the vehicle has to be accelerated to the desired speed. I will be using what? Throttle opening. By increasing the throttle opening, I can accelerate. By closing the throttle opening, I can decelerate. Whether I require acceleration or deceleration, my electronic engine will get the input, and based on that, it will decide the throttle opening. Okay. Then brake intervention, that is without driver intervention, it can apply the brake. See, this brake you should not confused with emergency braking. That is when you are traveling on a highway, suddenly one obstacle is going to come, say a cow or some other cycle is going to come. So in that ACC will not react. You have to react, and you have to put emergency braking. Okay? Whereas this one, ACC permit what? Soft braking. It will allow you to brake. That is a soft braking means it will be used to maintain the distance of the preceding vehicles. Okay. So the input is the driver inputs the desired speed and the gap. So those who are not able to see this video, the sound is not audible. It is in the link. You can take a snapshot of the link. Otherwise, you can go to the YouTube and type Bosch ACC. It will be available in the unit. Okay. So display elements, that is what are the units I am going to display in my ACC is what is the desired speed, what speed I have to travel, switch on status. Okay, whether I have to on this ACC or off, and desired time gap. Time gap means preceding vehicle started. After what time my vehicle have to start. Okay. So then follow on mode. Follow on mode means how much distance between me and that preceding vehicle. Okay. So this word you remember, mindless driving task. This word seems to be explaining well. That is, we can say it improves the driving style. It reduces the work from the driver. So everything can be termed as a single word, mindless driving task. Okay. So main use of ACC is it improves road safety as well as driver comfort also. Okay. So the system limits. Okay, there is a drawbacks. Which are the things the ACC can't do? No, for straight ahead driving and control of the vehicle, you have to ensure that the driver has to ensure that the vehicle is traveling straight ahead and he has to control the vehicle. And emergency braking and forced spacing. So everything the driver has to do. And already I told you speeds above 30 and less than 200 kilometer per hour, the ACC will be working. Beyond that, it will not be. Okay. So this is the layout of ACC. So this one is ECU, okay, radar sensor control unit. Okay, so you can see a radar sensor. It is emitting a beam. In the video, you might have seen a red color beam which is reflected back. Okay, green color is going from ACC vehicle to the preceding vehicle, and red color is getting reflected back. Okay, so it is a radar sensor, so that it will be measuring the distance of the preceding vehicle. And this one, yaw rate sensor, other thing, lateral acceleration. Why no? We have to follow the preceding vehicle accurately. Any deviation in this parameter will lead to error. That is, the safest distance can't be maintained, or sometimes it can lead to collision also. So this one will be the direct parameter, but indirectly other parameters also will be controlling this. That is, yaw, lateral acceleration. Lateral acceleration means I will be moving on in this direction. Okay, wheel speed, steering angle. So that inputs also needed for my ECU of ACC. So it will be selecting the object, and it will be a distance controller. Already I told you, controller. Based on this input, the distance controller will be sending the output, that is signals to different system, so that I can maintain the safest distance. It will be sending an input to ESP so that it can control my transmission as well as brake. TCS transmission as well as brake. And it will be sending to engine, that is a mototronic. We will be studying in engine. What do you mean by mototronic? So this is the layout of adaptive cruise control. You should be able to draw this sketch. Then this is not required. You can write this, but simply you can show this beam, and this can be simplified. Okay, if you want, you can draw. Otherwise, this is the main sketch you have to draw here. Okay. And next thing, parameters to be controlled in SI CA engine. This is the last topic in Unit 1. We will be seeing in the next class. And next class, I will be starting Unit 2. So today I have completed Unit 1. Only one topic is remaining. So next class, we will be seeing the second unit. Okay. So I will be sharing the timetable with you. That is a EVMS class timetable in the WhatsApp group. And I will be sharing the question paper, notes. I am referring the PPT from the notes only. I am not giving too much information, and I am not giving less information also. I am giving the required information. Okay, since the time gap is less, we will focus on exams. So whatever required for exam, we will discuss, so that based on this lecture, we'll be able to present well. Okay. So what is the requirement? We will be discussing. So if you are interested, you can add some more points also by referring the textbook. Okay? I will show you the prescribed textbook. That is, you go through the syllabus. That is, if anyone is interested in learning automotive electronics, there are two foreign authors book. Okay, William and it is you can be downloaded, or it can be available in the library also. You can get it. This is not recommended for examination point of view, for your projects, and for advanced learning. You can use this. Okay, for doing projects or to work in any industry. So they have described automotive electronics in detail. Too much intensive information will be available. Okay, so students who want to pursue a career in the automotive electronics, or they want to, that will be the current state of research. Okay, so you can refer this textbook for learning automotive electronics. Okay, you can refer Bosch handbook also. So what I will be covering from examination point of view. Additional information, you can refer some textbook also. In the meanwhile, I will be sharing some materials also. Okay. So we'll be seeing in the next class. Okay. Bye. ஸ்டாப் பண்ணிடுங்க சார்.